So that means you got to multiply whatever's out here by both things inside here. And I like to do these little doohickeys. I like to do that. And then I'm going to write it out. Some of you may not need to do this step, but I think as we're going through it, I'm going to write out what that means. 3 times x. How would I rewrite 3 times x? I could just write 3x, right? So this is equal to 3x plus, what's 3 times 6? 18. These and these two are equivalent. They mean the same thing. Okay, let's go over here. It doesn't matter if whatever you're multiplying by is on this side or this side. You still do the same thing. So I'm going to do the little, whatever you want to call them. That tells me that I got to multiply n times n and n times 5. And then I'm going to make this pretty. How do you write n times n? N squared, right? N squared. So that's that part. Plus, it just bothers me. You should always put the number where? In front. And if you don't, I probably wouldn't mark it wrong for now. But this is just the proper way to write it. Okay? All right. So here. As I went through this, I debated whether to have you do this, but I think you should always do this because when these things get long and complicated, signs are going to be your enemy. Okay? So if you have a minus, I would always recommend changing it to adding the opposite. That way, it lessens the chance you're going to screw up on your signs. Anytime you have a subtraction. So now you do the same thing. So this tells me I have to do y times y plus y times negative 12. And then let's make it pretty. What's y times y? Y squared plus, and then you just kind of switch the order here, negative 12y. Now I have a question for you. Would this be the same as this? And I don't care which way you write it, but I do prefer that you do this in the initial part. Okay? It's the same thing. Adding a negative and subtracting is the same thing. All right, so here. Again, we have a subtraction. I'm going to change that to adding the opposite. Adding a negative. I don't know how your teachers before said it. It doesn't matter. And then, just because the 9's over here doesn't mean I still have to multiply each thing. So I have 9 times 8 plus 9 times negative x. What's 9 times 8? 72 plus, how can I write this properly? Right, isn't this the same? This is the same as negative 9x. Is that the same thing? Can you all see that?
Yes.
Could you also write 72 minus 9x? That's fine. Okay. All right, here we go. So I got a bunch of negatives going on. Let's change this to adding an opposite. This is a subtraction. This is not, correct? Take a look. This isn't a subtraction. This is just a negative number. Yes, Amelia?
For some reason I got negative 9x minus 72.
No?
That was supposed to be positive.
Because the 8 is positive, isn't it?
Yeah, I like that.
So 9 times 8 is just positive 72. Okay? So you got to be careful with that. All right, let's distribute this negative 4 on each thing. If you write it out very carefully, and then you have negative 4 times negative 2. Negative 4y plus, what is this equal? Positive 8.
Oh, positive.
Okay, these are all different types of things you're going to see. So this is a negative, this is a subtraction. Sometimes people get that confused. This is just a negative number. You don't change it to adding the opposite. This you do. Distribute negative 5x times 4 plus negative 5x times negative x. So you can kind of see why I had you practice that baseball worksheet.
Is it okay if you did 8 plus negative 4y?
Yes. All right. So here, this becomes what? What does this first term become? Negative 20x. Plus, what does this second term become?
5x.
Yeah, this is really a 1 here, isn't it?
Yeah.
So it's negative 5 times negative 1. So it's positive 5x squared. Because you have to simplify this term and this term. Okay. Ooh, that looks a little funky. I'm going to rewrite this as this.
It's negative 1.
Can you see that? It's exactly the same thing. I just put a negative 1 here. I changed that to adding the opposite. Yeah? And then you distribute that negative 1. And then you simplify each term. This would be negative 3y in the beginning, plus 9. Or 9 minus 3y is the same thing.
We have to write that one's the second step you did right there. I just went straight to the negative.
Oh yeah, you don't have to write this out. I just do
No,
it for
the one right
this.
below
Oh yeah, no, you don't have to. I just do it for teaching.
it.
No, just to show you guys. Okay, so we have the 1/2 out here. This means I'm going to take half of 2n and half of 6. What's half of 2? 1. Can I write 1n? Sure, or I can just write n. And what's half of 6? 3. You guys seem like you're pretty confident with this, which is great. Okay, let's turn it over. Okay, identify the terms, the like terms, the coefficients, and the constant terms of this expression. Again, what's the difference between an expression and an equals?
Equals.
An expression and an equation. I kind of gave it away there. Expression has what?
No equals.
No equals. And you cannot solve for x if you just have an expression. Okay. All right, what are the terms? What is a term? You guys know? In this equation, or this expression, what's a term?
Negative 2.
That's one of them. Parker?
I guess the numbers are the expression.
Yeah, they're separated by the plus or minus. Okay. So I'm going to change this to adding a negative right here because that's a subtraction. Each term is whatever's separated by the plus sign. So each of these things are terms. So I'm going to list my terms as this, comma, negative 8, comma, 6x, comma, and 5. Those are all terms. Okay, so these are my terms. Which two are alike terms in here?
Negative 2x.
Well, that's the ones that have the what next to them? Yeah, they're alike. They each have an x next to them, so I'm going to list them like this. And then the numbers are also alike, because you could combine those. Negative 8, 5. Ooh, what's a coefficient? Does anybody know?
That's the
Megan, what do you think? What's a coefficient?
it's the number in front of the
Couldn't have said it better myself. The number in front of a variable. Okay? So we have two coefficients here, negative 2 and 6. The other numbers are not in front of a variable. Constant terms, what do you think that means? They stay the same always. There's two constant terms here. What do you think? Blake, what do you think? Two numbers in there are constant. They'll never change. Give me one of them. In this expression, which two numbers are constant that will never change? They don't have a variable next to them. Absolutely. Negative 8 and 5 are always going to be negative 8 and 5 because they don't have a number next to them that could change. A variable could change, which would cause that term to change. Okay, so Write the expression that is equivalent to this. We've got a lot of stuff going on here, which is absolutely fine. I like to think of it like this, DCS. What does that stand for? Dexter Community Schools. But in Burgess math class, it stands for distribute. The order you need to do things. Combine and solve. The order you should do things in when you have stuff like this. You cannot solve this. Why can't I solve this? Because there's no what?
Equals.
There's no equals. So I'm not going to be able to solve. But I can do the first two steps. Okay? So I'm going to rewrite it because I'm going to change the -2 to adding a -2. So I changed that subtraction to this. That's all I did. Now I distribute that 6. How come I don't multiply the 6 by the stuff over here? That's a common error people want to do. They want to do 6 times -2. Why can't I do that?
Because that plus sign, right?
Because of that plus sign. You cannot jump from here to here. Okay? You can only do this. All right. 6x plus 18. I'm just going to write it as 18 because 6 times 3 is 18. Then I'm going to distribute that -2 to this set of parentheses. So it's -2 times 8. What's -2 times 8? -16 plus -2x. All right, I did the distributing. What do I have to do next to simplify? Combine. Okay? So the number or the terms that have x's next to them, I can combine those. And then these terms are just constant, and I can combine those. So if I have 6 x's, I take away 2 x's, how many x's do I have left? 4x. So I took care of those two. I have 18, take away 16, what do I got left? 2. This is the most simplified that I can go. I cannot solve because I don't have a what? Equal sign. I'm keep saying that because people will try and solve for x. Can't do it. All right, last one. Miss Jenkins rented a rototiller from a garden shop. The rental charge is $28 per day for the first 2 days, and then $15 per day for each additional day. If Miss Jenkins kept the rototiller for 13 days, what was the total rental charge? What do you think? How do I start this? How many days did she keep it total? 13 days, right? How much did the first 2 days cost her each day? So I have 2 days at $28, correct? I'm going to add to that, how many days does she have left after we take those 2 away? 11, and how much were each of those days? So 11 times 15. I'm going to put a dollar sign here just so I know that that's money. If I combine those two, I'm going to come up with her total cost, yes? Which I don't have here in front of me. 56 plus 11 times 15. $221. Everybody follow me on that one?
Yeah.
Cool. All right. So you have